Hey folks, Mr. Dell here. We are looking at different types of graphs of data. In this case, we're gonna do a stem and leaf plot as well as a histogram, and then talk about that data in interpreting it. So this is something I'm pulling. This problem is from CPM, and it's from course 2, and this is section 8 point, no, not 8, sorry, 7.1.3. Okay, number 7-38. So it says read the math notes in the box in this section. So that there are some math notes talking about data in this lesson and the previous lesson about box plots and different types of statistical analysis. So I'm going to go through and review that, but yet in the context of this question. So it says here the coach of the girls basketball team weighed each other. The weights in pounds were these weights, right? So there's this list of weights. So the girls basketball team, there was these girls that weighed 120, 122, 126, 130, 133, et cetera, all to 142. It says to make a stem and leaf plot of the team players' weights. Now, remember, a stem and leaf plot is taking your numbers and just putting them in a systematic order, right? So there's always a stem and on one side, and then there's always the leaf on the other side. And the leaf is normally, in this case, is going to be our ones place, but your stem is your tens or hundreds. So we'll use tens as our place value. So, and we do it in order. So if I look at my very smallest number, I have 106. So my stem would be the 1, 0, 10, tens, and then the 6 for the ones place, right? So there's 106. So that's my only one that's that has a 10. So now I go to my 11 for my tens. So that 11 is here and it's leaf. So that's the stem. And it looks like I have a 112 and a 115. So I'm going to put a 2 and then a 5. Okay. So you just list out the numbers. And then we have, let's see, I think that's it for that one. And then my next tens is my 120s, right? My 12. So my stem is 12. And it looks like I have the lowest one is 120. So my leaf would be a 0. And then my next I have 2 of those. So I actually list them both. Almost missed that. So I should probably cross these off as I go, just so that way I know I've dealt with them. I've dealt with those. I've dealt with that. I've dealt with that one. Okay. So now I've got 122. So I'm going to put 0, now 2. I dealt with that one. And then 126 looks like it's the next. So 126, right? So this is the leaves to all the 120s. So then my next stem, cross that off, is going to be the 130s or the 13 for my stem. And my 13 has, let's see, I've got a 0, 130, 133. So it looks like those two. So 0 and 3. So for 130 and 133. My last, I'll squeeze it in there, is going to be the 14 for my stem. And my 2 numbers are 142 and 147. So this is this stem and leaf plot based on the data that I have up there. Okay. All right. Now, then it says make a histogram. A histogram, remember, a histogram is looking at the numbers and putting them in a category, in a subcategory, right? So if I think about my numbers here, there's the same weights. So if I want to group my weights, I'm going to put them in groups. So my first group here, I would say, would be between 100 and 109, right? So that's my first group. So between 100 and 109. And so then I'm going to determine how many of those numbers are there between 100 and 109. And then I'm going to have my numbers, and I'll go and I'll just do this. I think my largest numbers would be 4. So I'll skip by 2s. So that's 1, 2, 3, 4, 5. So my first group then would be up to, looks like there's only one number, right? 106 is, I can do this down here. 106 is the only number that falls within this category, this sub range. And you want your scale to be equal. So I'm going by tens. If you notice, so 100 to 109. So my next range is going to be 110 to 119. That's my next range. So how many numbers are, so I did my 106. How many numbers are between 110 and 119? Looks like 1, 2. So now this time I'm going to take my box, my histogram, and bring it up to 2. Then my next category I'm going to have is 120 to 129. You notice I'm having equal subgroups here, my equal subgroups. So in the 20s, there's 1, 2, 3. Looks like 3, right? Actually, wait, I missed one. 4. There it is. So 1, 2, 3, 4 of them. So I'm going to go all the way up to 4. And that's going to be that category. And then I'm at now 130 to 139 is my next category. And that's in the 130s. There's 1, 2. So again, back to 2. So that's at 2. Do you see where I'm come up with these the histogram plot here? And then the last category is 140 to 149. And it looks like I just have 2 again. So that right there is my histogram based on the data. Okay. Oh, and I should label. This is the weights. We would say this is the weights of the girls. I can just do it that way. Weights. So that way I know those represent weights. And that it's always the count. This is the count or the number of, if you want to consider that. Okay, the frequency. That's a better word. This is the frequency. This is the frequency. Okay, the count or the frequency. All right. Now, from there, part C, we are looking at, so to describe the shape and spread of the data, symmetric or not symmetric. So if you look at this data, it starts low, goes up to the middle, and goes back down. So we would call that symmetric. That is symmetric, right? So it's symmetric, and it's got only one peak because it goes up in one peak. And then it wants to know if it's tightly packed together or widely spread out. And I would say it's relatively closely packed, right? Because it doesn't have high outliers on the outside. So we would say it's also tightly packed together. So if you're going to define this, it's symmetric with one peak, tightly packed together. And then does this data have any outliers? I don't see. An outliers would be the fact that if there was some random bar way out here or random numbers down in the higher numbers. So no outliers. Okay. Last couple questions. Which measure of center, mean, or median would be appropriate to describe the typical weight? So I think for this one, I would say either the mean or median would be appropriate because when you think of the middle, this middle data is my median, but it also kind of tendency to tell me that that's probably going to be my mean as well, my average. So we could use mean. Well, that's this question right here. So I would say mean or median because all the data is really in the middle. It's all centered data. I'll say it that way, centered data, and that's the reason why. So mean or median. What is typical weight of a player? So what we want to find out for E is what is the mean? Typical weight would be my mean. So let's find my mean. Or median, we can do either one, but I'm going to use the mean in this case. So mean, remember what we do to find mean is add all the data and divide by the number of numbers. So I'll just do this quickly. So I'm going to say 120 plus 122 plus 126 plus, you can't see what I'm doing there, plus 130 plus 133 plus 147 plus 115 plus 106 plus 120 plus 112 and plus 142 32. I think I got everything. So that's all my data. When I add that up and then divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces of data. So divide by 11, and that should be my mean. So my mean is 124.8, and I'm going to round it to the hundredths place, round it to that place, so 0.2. So the mean is going to be 124 and 82 hundredths. So that would be the typical weight, the average, and that's our mean. Last one, range. So how do you find range? Remember, range is the distance between smallest and largest, right? So the distance between the smallest and the largest. And so my smallest piece of data, if we go back to the list of data, you've got it in front of you there, is 106. So that's my smallest, and my largest is 147. So really what I need to do is take 147, I said 47 and I wrote a 46, 147 minus 106. That's my distance between them. And so I'm going to end up with 31. So my range is equal to 31. All right? And that's that spread. You say the distance between the smallest and largest, or you could say the spread between the distance, the smallest, largest. Okay, there we have it.